Example 6. Solve the equation over the interval 0 to 2 pi and also for all solutions. The equation here is 4 times the cosine squared of x minus 1 is equal to 0. All right, this one is a little more obvious than the last one, that this is quadratic. We have a single trigonometric function, cosine of x, and the highest power in the entire equation is 2. Okay, so luckily one side is equal to 0 for us already. So we can go ahead and factor the non-zero side or even try the quadratic formula. But this is a really great instance to try to extract square roots on it. So let me show you how that works, okay? When you extract square roots, what that means is you have something raised to a power equal to a number, okay? That's when you want to use this process, okay? It's a shortcut. You can get you to the solutions much quicker than factoring or the quadratic formula can. Okay, so if you have something squared is equal to a number, all you have to do to get the something is take the square root of both sides. Okay, so let me just rewrite this. So what you would do here is you would take the square root of both sides, but on the number part, you can't forget to put a plus or minus out front. Okay, and so then the square and the square root would cancel on the left, and that would leave you with plus or minus the square root of the number. Okay, so that's what we're going to do here. Okay, so even though it's really great that this side is already 0, the right side is already 0, we're going to go ahead and try to isolate the something squared. Okay, because that's what you want to do here. You want to isolate the something squared. So our something squared is going to be the cosine squared of x. We need to get that by itself on one side. Okay, so we're going to start by adding 1 to both sides. Okay, we're going to get 4 times the cosine squared of x is equal to 1. Okay, we're almost there. And then to isolate the cosine squared of x, we're going to divide by 4. Okay, so we get the cosine squared of x is equal to 1/4. Okay, so we have something squared is equal to a number. Okay, this is when you can extract square roots. Okay, so what we're going to do now, I'm just going to rewrite what I have. Okay, you basically, okay, you have something squared equal to a number. Okay, to get rid of the square, you're going to take the square root. If you do it to one side, you have to do it to the other side. Okay, and on the number part, you can't forget to put a plus or minus out front. I always tell people, remember the example of +4. Okay, you can square +2 to get +4, but you can also square -2 to get +4. Okay, all right, so then on the left side, what's going to happen here is that the square and the square roots cancel. Okay, square and square root cancel, leaving you with just cosine x. Okay, and then, because remember, what's under the square root of x? Cosine squared of x. That's cosine x times cosine x. Okay, on the right, this will be plus or minus the square root of 1/4. Okay, we can do some work with this quantity on the right. Okay, this is plus or minus the square root of a fraction, so you can break it up into the square root of the top over the square root of the bottom. So this is really this plus or minus the square, or sorry, plus or minus 1/2. Square root of 1 is 1, square root of 4 is 2. Okay, so that tells us that the cosine of x is plus or minus 1/2. Okay, so we need to go to our unit circle and figure out which angles between 0 and 2 pi have a cosine of either +1/2 or -1/2. Okay, if you want to, you can write this out into two separate equations. So first of all, we need the cosine of x to be +1/2, and then secondly, we need the cosine of x to be -1/2. Okay, do that if it helps you. So let me go to the unit circle here. Okay, so first of all, we need the cosine of x to be +1/2, and then the second equation is that we need the cosine of x to be -1/2. Okay, I'll start with the first equation. So we know that the cosine of x is associated with the x coordinate. Okay, so we need to look, well, here cosine of x is 1/2. The cosine value is positive, So cosine is positive in quadrants 1 and 4. Okay, so that's where we need to be looking here. So if we look in quadrants 1 and 4, which angles have an x-coordinate of 1/2? Okay, so right here. So the cosine of pi over 3 is going to be 1/2. Okay, and then if we go down to the fourth quadrant, we see a positive 1/2 as the x-coordinate right here. So that's going to be 5 pi over 3. Okay, so those are going to be our two angles that work here. Okay, so oops, I used a theta. X is got to be either pi over 3 or 5 pi over 3. Okay, if you take the cosine of both of those angles, you should get positive 1/2. So let me come back over here and write that down. So for this first equation, x needs to be pi over 3 or 5 pi over 3. Okay, these are both between 0 and 2 pi, so I can go ahead and put them in the solutions box. Okay, and then if I return to my unit circle so that I can figure out this other equation in red. Okay, so again, we're dealing with a cosine. We know that the cosine is the x-coordinate. Okay, and now we have a negative cosine value. Okay, so cosine is negative in quadrants 2 and 3. And so we just need to scan the circle for an angle whose x-coordinate is negative 1/2. Okay, so that's going to be right here. So 2 pi over 3 is going to be a solution. And then also down here, we have an x-coordinate of negative 1/2, so that's going to be 4 pi over 3. Okay, so we get two solutions out of this equation. So x can be 2 pi over 3, or it can be 4 pi over 3. The cosine of those angles is negative 1/2. Okay, so we come back over here. We'll write this down for the second equation. X can either be 2 pi over 3, or it can be 4 pi over 3. Okay, so again, these are within one revolution of the unit circle. They're between 0 and 2 pi, so we can throw them in the solution box. Okay, so there are 4 solutions for x that make our original equation 4 cosine squared of x minus 1 equals 0 a true statement. They are pi over 3, 5 pi over 3, 2 pi over 3, and 4 pi over 3. Okay, so now it's time to generalize these solutions. Okay, so you can definitely take each of these guys and add integer multiples of the period, and you can write 4 separate statements if you want to. Okay, we're dealing with cosine. The period of cosine is 2 pi. Okay, so like I said, you could make 4 different statements here. Okay, take each one pi over 3 plus n times 2 pi, and then 5 pi over 3 plus n times 2 pi, and then do the same thing for the other two. You can make this one a little more concise if you choose to. If you notice the relationship here, if you look at the yellow angles, okay, I'm sorry, not the yellow angles. If we look on the diagonals here, okay, so like if we look at this angle versus, oops, let me just draw that a little better. Okay, so if we did this, okay, these two are opposite. Pi over 3 and 4 pi over 3 are opposite each other on the unit circle. Okay, and actually, if you subtract them, you're going to get 3 pi over 3, which is just pi. Okay, so what happens here is if you take pi over 3 and add pi to it, you're going to get 4 pi over 3. And then if you add pi again, you're going to end up at an angle coterminal with pi over 3. Okay, you're going to end up at 7 pi over 3. Okay, and so basically what's happening here, because of that, you can just take pi over 3 and add integer multiples of pi. Okay, because that's going to catch the 4 pi over 3. Okay, so you can do that, and that's because they are opposite each other along a diagonal on the unit circle. Okay, the same thing is happening with the other two angles, so 2 pi over 3 and 5 pi over 3. They're opposite each other. Okay, so if you did 5 pi over 3 minus 2 pi over 3, that's going to give you 3 pi over 3, or pi. Okay, so if you start at 2 pi over 3 and you add pi, you're going to get the 5 pi over 3, and then you add you take 5 pi over 3 and you add pi over 3. Okay, let me say this again. If you take pi over 3 and you add pi, half a circle, that will get you to 5 pi over 3. Add pi again, half a circle, that will get you to coterminal with 2 pi over 3, and so on. So you only really need to add integer multiples of pi here. Okay, that's how you can make it the most concise. So let me go ahead and jot that down. Okay, so we can say 2 pi over 3 plus n times pi. Okay, and again, this is where n is an integer. Okay, this is how you can make the statements most concise. But again, at the end of the day, if you didn't see that, it is perfectly fine to just write them out individually. Okay, so I'll put a big or here. Okay, you can just say pi over 3 plus n times 2 pi, and then the second equation, 5 pi over 3 plus n times 2 pi, and then the third equation, 2 pi over 3 plus n times 2 pi, and then the last equation, you can just say 4 pi over 3 plus n times 2 pi. Okay, at the end of the day, if you get stuck writing all the solutions, just take every single equation that falls between one period, okay, and add integer multiples of the period. So for here, we had 4 solutions within one period of cosine, which is 2 pi. So we take all 4 of them and just add integer multiples of 2 pi. Okay, if you do see how to condense that into what I have in the answer box, that's fine. Okay, but if you don't, no big deal, just write them all out separately.